Hello everyone, my name is Rilla Dinesh from CSITA section. Subject probability and statistics. My tech talk concept is random vectors and its probability function. Okay, let's see about random vectors and its probability functions. First, random vectors are its probability functions. Introduction. Random vectors are the set of variables that are interrelated and have a probability distribution. They are commonly used in statistics, engineering, and physics. Probability functions describes the likelihood of a different value that the random vectors can take. It is a vector whose value depends on the outcomes of the experiment. Okay, random variable. Okay, random vectors. Random vector is a collection of a random variable that have multiple dimensions. Each dimension represents its different attributes or characteristics. It can be represented as a column vector or row vector. Each element of the vector is random variable. The probability function of a random vector is used to describe the likelihood of a different outcomes. The component of a random vector are pairwise independent if every pair of a component is independent. Okay, random vectors. An n-dimensional random vector consists of n random variables all associated with the same probability space outcomes dedicated the value of every random variable. Example, 2D random vector whereas v equals to in square bracket x and y, x is equals to reaction time, y is a arm length where sample m times from v1, v2, v3. It is n cross n matrix. We can see here. Okay, ex is equals to e of x1 expected value. It's known as expected value or average we can say, or else we can say mean. E of x1, e of x to e of x is equals to mean 1, mean 2, infinity mean n. Okay, probability functions of random vector. Probability function of random vector describes the likelihood of a different outcomes. The probability functions is functions of a multiple variables. The probability function can be discrete or continuous. There are different types of probability functions, random vectors. Let's look into it. First one, joint probability function. The joint probability function describes the probability of all possible outcomes of a random vector. The joint probability function can be expressed as a probability density function for continuous random vector. The joint probability function can be expressed as a probability mass function or discrete random vector. It takes into account the probability of each individual outcomes and their relationship with each other. Discrete joint probability distribution. X and y are independent, whereas f of x comma y can be written as f of x into f of y, whereas x and y are dependent. Okay. Marginal probability function. The marginal probability function describes the probability of a single random variable within a random vector. The marginal probability function can be found by summing or integrating over all other variables. The marginal probability function can be to calculated expected values, the variance of an individual variable. Okay, the marginal probability function is represented by a probability density function for continuous random variable or a probability mass function or for discrete random variable. Marginal probability distribution. Example, I will zoom it where. Example, the marginal probability distribution of x and v. Y equals to number of r of time city name is stated 4, 3, 2, 1. Whereas x number of bars of a signal strength, where here we can see. This is an example of a marginal probability. Okay, conditional probability function. The conditional probability function describes the probability of a random variable given the value of another variable. The conditional probability function can be found using Bayes' theorem. The conditional probability function can be used to calculate the conditional expected values. and variance. The conditional probability function is represented by the probability density function for continuous variable or probability mass function for discrete variables. Conditional probability contains a condition that may limit the sample space for any event. Can be written with a notation P, B, or A, which reads the probability of a B given event A. How likely is one event to happen given the another event has happened? Percentage probability based on the row or column, the total of the given event for two-way table problem. More complex given problems may require use formula. There is a formula. Probability of A given B equals to P A or B equals to P of A and B divided by P of B. This is a conditional probability. This is the formula of a conditional probability. Okay, let's see the expectation and covariance. Expectation of a random vector is expected value of each individual variable. The variance of a random vector measured the degree of it to which two variables change together. The variance matrix is a matrix that contains the covariance between all pair of variables in random vector. Okay, wait, I will show that. Yes, so expected value is also known as average ex. Expected value is also known as average and nu. Here this is a continuous, I think so. Okay, sigma xi p of I, it is the product of value and its corresponding probability. You can see here e of x is equals to x1 p1 plus x2 p2 up to infinity xk pk. This is the expected value, is not necessary as a possible outcome. Okay, let's see the applications of random vectors. Random vectors can be used to analyze the data and make predictions. Random vectors are used to statistically analyze machine learning and even in the data science and in engineering. They can be used to model complex system and relationship between variables. They are also used in simulation and Monte Carlo method. Limitations of random vectors. Random vectors can only the model linear relationship between variables. They assume that the variables are normally distributed and have a constant variance matrix. They may not accurately model complex system with non-linear relationship or non-normal distribution. Okay, application of random vectors. It explaining that it is applications of a random vectors. Random vectors are also used in analyzing data and make predictions. It is used to prediction the analyzing data. By using random vectors, we can analyze and predictions. Random variables are based on prediction only. Random vectors are used to statistically analysis, and it is also used in machine learning and data science. They can be used to model complex system and relationship between variables. And by using the random vectors, we can find the relationship between the complex variables. Okay, they are also used in Monte Carlo methods. Okay, this is the one method. Limitation. They every theory has a one limitations. Here, random vectors can only the model of linear relationship between variables. It will be only model linear relationship between only two variables. They assumed that variables are normally distributed and have a constant variance matrix where they are not constant. They failed to explain this variance matrix. They may not accurately model complex system with non-linear relationship or non-normal distribution. They fail to explain the non-linear relationship and non-normal distribution. Now let me see now conclusion. The random vectors and their probability functions are essential tool in the probability theory and statistics. It is an important tool. It is important tool. One of these ones of a tool. It is a one of the important tool in the probability theory. Understanding the properties of a random vectors allows the analysis of complex system and prediction of future outcomes. Okay. Further study of a random vectors can lead a new insight and applications. It is used to inside the applications, and one is to predict the outcomes, and another one is it is a tool for probability theory. The allow for modeling the analysis of complex system and relationship between variables. It is a modeling complex relations between variables. It is important consider their limitations and assumptions when applying them to a real world problems. Therefore, random vectors and its probability functions are very much useful in mathematicians to solve the problems quickly and easily. This is a conclusion of a probable random variables. Okay, thank you.